simple way to understand differentiation is by looking at a car's speedometer. There are two important speed values a car gives you. First, your average speed. That's like saying how fast you were going over the whole trip. Second, your instantaneous speed. That's the exact speed you're going right now at that precise moment. Differentiation is directly linked to your instantaneous speed. Let me explain. To understand that properly, we need to look at a graph of what's happening. Because, as you probably know by now, most of calculus revolves around functions. Don't stress at all about how the graph is drawn. We'll get to that later. For now, it's just important that you follow the explanation so we can build a solid understanding of what differentiation actually does and how insanely powerful it is. We're going to represent the movement of the car using distance and time, because we know speed is basically just another way of saying distance divided by time. The function represents the movement of the car from where we started to where we are now. So, at this exact moment, we looked down at the car's speedometer and saw this information. Let's break down what each of these values actually means in terms of the graph. We'll start with average speed. Average is exactly what it sounds like, meaning it's the overall speed from where you started to where you are now. We can represent that with a dotted line on the graph. We can now easily work out the slope of that dotted line using our usual slope formula, which is the difference in y values divided by the difference in x values. We know the point where the function started is the coordinate 0, 0. And let's say the coordinate where we are now on the graph is 0.008, 0.25. If we work out the slope using the formula, it will look like this. What's super interesting to see here is that the answer we got when we worked out the slope between the start point and where we are now is exactly the same as what the car's speedometer showed for the average speed. Wow, but how does that actually work? Let me explain. Why does slope give us speed? It feels kind of weird to think it does, but if we look closer at the slope formula, it actually makes perfect sense. Remember, slope is the difference in y values divided by the difference in x values. Now, when we look at our function, we can see the y-axis represents distance in miles, and the x-axis represents time in hours. So basically, what the slope formula is really telling us is, take your distance and divide it by your time. And we know when you divide distance by time, you get speed. That's exactly why the slope between those 2 points gives us the average speed between them. Now, with this principle in mind, that slope gives us speed, let's go back to the car's speedometer and figure out how to work out the instantaneous speed. We know the average speed was the speed between where we started and where we are now on the function, represented by that dotted line. So, if we want the instantaneous speed at the exact point where we are now, that means we need to work out the slope right at that specific point. And this is exactly where the challenge starts. See, we've got the coordinates of the point where we are now, and we know that if we work out the slope of the function at that point, we'll get our speed. But here's the problem. Our usual slope formula, the one we all know, needs 2 sets of points to calculate slope. We can't use that formula if we've only got 1 point. That's why we need a brand new level of maths to handle this. And this is where we meet our new best friend, differentiation. Differentiation is the maths tool that allows us to calculate the slope at an exact specific point. And that means we can now work out the instantaneous speed at a specific moment. Here's how it works. We differentiate the function, and wherever we want the instantaneous speed, we simply plug in the x value of that point, and boom, that gives us the instantaneous speed at that exact spot. Magic. Don't stress at all about how we actually differentiate. In the next video, we're going to learn exactly how to do it, step by step. For now, the important thing to understand is this. The real power of differentiation is that it allows us to get the slope at one specific point on a function. It might not feel like a superpower just yet, but the applications are literally endless. Speed is just one example, but what differentiation really allows us to do is calculate the instantaneous rate of change. In other words, how fast something is changing at a specific moment. Think about working out the pressure change inside a rocket 0.001 seconds after launch, or the tension change in an airplane wing the moment it leaves the runway. The possibilities are endless. Winging calculus is like winging a parachute jump, fun until the ground shows up. Ditch the 30 open YouTube tabs at 2 a.m. trying to integrate and grab my ebook course, step-by-step fixes and shortcuts. Cheaper than your monthly coffee bill and way easier than explaining a flatlining GPA. Course link in the description. If this helped, smash like and subscribe. See you next time. Cheers!